Hello students. Hello students. Good evening everyone. Drop a message if you are getting the voice clearly or not. Drop a message if you are getting the voice clearly. Voice is audible or not. And are you able to see the whiteboard? Are you able to see the whiteboard? Drop a message if it is audible means yes audible. Just type a message as yes it is audible and send the message in the chat box. Live chat. Yes and good evening. Good evening. Pretty. Very good. Thank you. Thank you. Yes. Yeah. Let us go ahead now. Let us go ahead. So, in the morning session, we have discussed, I think, till question number 15, 16, 17 also completed. Okay. Question number 17 also completed. Till 17 only I have discussed. 17. Yeah. And any other questions? Yes, somewhere. I think that's it. 17 questions. I have discussed that. 17 questions. Let's see the next ones. 19th one. Mhm. So for the 17th one, this is the answer. And for 19th one, so what is given here and what you are asked to find. Let us see this. Um, yeah, it is given that. Let me take this page to the down so that we need some space for explanation part. Okay. Okay, fine. So question number 19. Question number 19. The question is, a stone of mass 16 kg is attached to a string 144-meter long and is whirled in a horizontal circle on a smooth surface. The maximum tension in the string, the maximum tension in the string that it can withstand is 16 Newton. That it can withstand is 16 Newton. The maximum velocity of revolution, the maximum velocity of revolution that can be given to the stone without breaking it will be, okay. What is this and how to deal with it? Let me do somewhere here. Let's take this exactly this page down to see. Can I take this page here down? Control V. Oh, okay, it is overlapped. Okay, let's try to look here. So question number 17. Sorry, 19. Let me drag this up. Yes, so that we want to work out 19th question. To keep this nearby, yeah, keep this nearby to be visible. Yeah, I hope it is okay now. Okay, guys. Now this is the question number 19. Let us see now. Question number 19. So it is given that yeah, a stone of mass 16 kg So it is whirling in a horizontal circle. It is attached to a thread and it is whirling in a horizontal circle. So it is a center and here is a stone. This length of this is acting like the radius of the circular path. Yes, its mass is 16 kg and they are attached to a string of length of 144 meter. So here radius is nothing but length, it is equal to 144 meter, and mass m is given as 16 kg and is whirled in a horizontal circle and a smooth surface, means there is no friction. The maximum tension in the string that it can withstand is maximum tension in the string that it can withstand is 16 Newton. Okay, the maximum possible velocity of the velocity of revolution that it can give the stone without breaking is, without breaking, how much faster you can rotate. If you are increasing the speed at a particular speed, if you are increasing speed, tension in the string will increases. Tension will act in this direction, so tension will increases. Okay, the tension is providing here centripetal force, actually speaking. Tension will provide centripetal force. So tension is equal to centripetal force. What is that? mv square by r. If you increase the speed, tension also increases. At a particular maximum velocity, it breaks. So the maximum tension force it can withstand is 60 Newton only. So what is that maximum velocity at which it can break? At which that breaking strength can be this one is the question. So Vmax. Vmax, this will be Vmax square, Vmax square. So Vmax square is equal to TR by M, or Vmax is equal to square root of TR by M. Directly you can take it. This is equal to square root of T is 16, R is radius 144, 144 divided by M is 16. So here you can say 16, 16 gets cancelled. 144, square root of 144 is, right? What is square root of 144? 12. 12. So Vmax is equal to 12 meter per seconds. 12 meter per seconds. So what is that option? Option 4 is the right one. Option 4 is the right one. I hope it is clear for you. Yes. Next question number 20 is another track 21. So what is given here? Let us see this next. 21. If mass, speed and radius of a circle of a particle moving uniformly in a circular path are all increased by 50%. Increased by 50%. 50% means doubled. Every parameter is doubled. So increased by 50%. Not doubled. Since it is, let us say mass is m, mass is increased by 50% means 50% means half of it is added to it. So initial mass, if it is m, so 50% extra is m by 2 will be added to that. That is the meaning of it. Okay, that is the meaning of it. Then if it is, if all of these are increased by 50%, the necessary centripetal force required to maintain the body moving in circular path will have to be increased by, when the mass is m, velocity is v, radius is r, then the centripetal force will be mv square by r. If all of these are increased by 50%, what would be the necessary centripetal force required to increase percentage of increase of that to keep that in circular path is the question. So how to deal with this? Let us see question number 21. Question number 21. Right. Let us say the initial mass of a body m1 is equal to m, and the velocity of the body is v1 is equal to v, and radius of the body r1 is equal to r. They are in a circular path. They are in a circular path. When the mass increases by 50%, that is m2 is equal to m plus 50% means m by 2. M by 2, that becomes 2m plus m is 3m by 2. M2 is 3m by 2, and v2 is equal to v plus v by 2, which is equal to 3v by 2, and r2 is equal to r plus r by 2 is equal to 3r by 2. Then what is the uh, change in centripetal force required to maintain the circular path? So in this case, let us say centripetal force required to keep the body in circular motion is Fc, which is equal to mv square by r. Here, when these values are changes by like this, then what should be change in centripetal force? That is percentage change in centripetal force. You can express it as F delta Fc by Fc into 100 is equal to what? Because options are given in percentage. So delta FC by FC gives you fractional change. So this gives you percentage change. We want percentage change or percentage increase. Percentage change. What kind of change it is? Increase or decrease? Increase. How much you have to increase so that it should be in circular motion is the question. So this can be worked out. How can you work out this one? This is, you can say, FC1 initial one. This is FC1 initial one. So final one is what? If you take delta FC, you can take it as a delta FC2 minus a delta FC2 minus FC1 by FC1. Okay. So in that way, if you consider, that way if you consider, what you will get, what you can get. Uh, so F2 minus F1 by F1, FC2 minus FC1, FC2 minus FC1 by FC1. So what is FC1? This is FC1. This is FC1. And what is FC2? In this case, FC2. So we have to find this. For that purpose, let us write FC2 is equal to FC2 is equal to M2 V2 square by R2. M2 is what? 3M by 2. 3m by 2 and v2 square. V2 is 3v by 2 whole square, so it becomes 9v square by 4 whole divided by 1 divided by r2. R2 is 3r by 2, so 2 comes here. And simplifying this further in terms of mu square by r, if you want to write, how can you write? Let us try to understand. So so how can you write this then? FC2 is equal to 3 by 2, 9 by 4, 3 by 2, 9 by 4 into 2 by 3, 2 by 3 into m v square by r. M v square by r. M v square by r. So can you cancel this further? Any terms can cancel? This 2 gets cancelled. 3 times gets cancelled. Anything else? This cannot cancel. So what it becomes then? That's it. So so you can express this as this further as what is this? M2 is what? 3 by 2, right? Why you have taken 9 by 2? 3 by 2 it is. Not 9 by 2. It is 3 by 2, guys. 3 by 2. So you can say 3 into 3 is 9. 9 by 4 then it is equal to. This is equal to 9 by 4 mv square by r. 9 by 4 mv square by r. mv square by r is fc1. So you can take this as a 9 by 4. 9 by 4 fc1 is fc2. Is fc2. Now try to find out this. What is that? Here only you can do it, otherwise to save the space. Okay, let us do down. Delta fc by fc1 into 100 we want is equal to fc2 minus fc1 divided by fc1 into 100 is equal to fc2 is 9 by 4. 9 by 4 fc1 minus fc1 only, let us take, divided by fc1. Just a second, guys. Yeah, so we can say, or it is fc1 is common, right? You can take this is common. Okay, so if you take this common, then you will get 9 by 4 minus 1 becomes 5 by 4. 5 by 4 into fc1 by fc1 gets cancelled now. So it becomes what? 5 by 4. 5 by 4. Is that's it, or anything else is there? 5 by 4 into 100. We forgot here into 100, guys. Into 100. Okay. So 4, how many times it cancel? 4 twos and 4 twos 8. 2 is there, 4 fives, 25. So 25 fives, 125. We can write it as 125%. This is called as percentage change. So delta FC by FC1 into 100 is equal to 125%. So I hope it is clear for you. So which option is the right one for here? Second option, the second option, 125%. This is how we have to work it out. Next, question number 21 is done. Let us see next. 22 will be another type. 23. Let us see 23. Let us see 23. So here you can cross check this values. So 19th one, 16, right? 12. 12. This is 125%. Next 23, 23rd one. Yeah. Let us check this. Let us remove this. Yes. Next, this also let us copy it and bring it down. So 23 you want. Yes. Yes, we can understand 22. 20%. Sorry guys. Just a minute. Just a minute. Oh, right. Just a second. Yes. Right. So question number 23. Now we want to go through this question. Question number 23. So it is given that a motorcyclist moving with a velocity of 72 km per hour on a flat road takes a turn on the road at a point where the radius of curvature of the road is 20 meters. The acceleration due to gravity is 10 meters per second square. In order to avoid skidding, he must not bend with respect to vertical plane by the angle greater than. So that means what is the maximum angle he can bend. So in the revision point during the revision the previous study I also have mentioned this point. What is that? uh, when a vehicle is bending without considering the friction, the maximum speed can be expressed as, what is that question number 23? Maximum speed can be expressed as v is equal to square root of rg tan theta. Rg tan theta I have to consider. So this is what you should have to remember. The maximum speed of the vehicle, it can take a turn with only the angle of turn without considering the friction. So here the question is, a motorcycle is moving with a speed is given here. V is equal to how much? 72 kmph. You can convert this into meter per second because the options we need to have in SI units. So it is equal to 72 into 5 by 18 meter per second. So it is equal to how much? So 18 4 so it is equal to 20 meter per seconds, right? 18 4 is 72. So 4 8s 32. So 3 414 plus 3 7 72 yes. So we can take it as 20 meter per second. V is 20 meter per second. So a cyclist is moving with the speed of this much on a flat road and takes a turn on the road at a point where the radius of curvature of the road is r is equal to 20 meters. R is equal to 20 meters. The acceleration due to gravity at that point g is equal to 10 meter per second square. In order to avoid skidding, he must not bend by the maximum angle of this is what you are asked to find. What should be theta is the question. So in this, theta is here. So if we square on both sides, we get v square. Just a second, guys. Yeah, what happened to this? Something happened to this. The file has got stuck. So it is not selecting the pen. Just a second, guys. Do one thing. Just I'll be as I hope you are getting my voice right. There is some issue with this thing. Let me close. Okay, now it is selected. Okay, fine. Otherwise, just if I may close this and if I restart, then it may work fine. Yeah. Okay, let's go ahead now. We have less time. So if you square on both sides, you'll get v square is equal to rg tan theta. So tan theta is equal to v square by rg, and hence theta is equal to tan inverse of v square by rg we get. So if you substitute these values, we get tan inverse of tan inverse of v square will be what is v 20. So 20 square means 20 into 20 by r is 2, g is 10. So 20 gets cancelled. That's it. uh, what is the r is not to 20 meters, that's 20. So 20 gets cancelled here. In this 0 1 0 gets cancelled, we get 2 remains. So we can say theta will be equal to tan inverse of 2. So if you check this option, tan inverse of 2 will be correct. Second option is theta equal to tan inverse of 2. Whereas the next one 20 not fourth and 25th one 25th. Right, guys. Question number 25. Question number 25. 25. Let us work out this here only then. Question number 25. Just like in previous case. Question number 25. Yeah. Let us let us copy the data first. Then we'll go ahead. What is given? Keeping the angular banking constant, if the radius of curvature is made 4 times, so that means initial radius of curvature r1 is equal to r, and r2 is equal to 4 times radius of curvature made 4 times the percentage increase in maximum speed. So if initial when r1 is r, v1 is v. If this becomes 4r, what should be v2, and hence percentage and hence percentage increase in maximum speed with which the vehicle can travel circular road. Percentage change in v delta v by v1 is equal into 100 is equal to what is the question. So by keeping the theta constant, by keeping the theta constant, how can you consider here when a vehicle is moving on a circular road? When a vehicle is moving on a circular road, you have to just keep in mind that uh, the same way, the same relation, if you can make use here, v square is equal to rg tan theta. V square is equal to rg tan theta. So from this you can say v square is equal to rg tan theta. If tan theta is constant, and of course g is also constant, then what will be the variable here? V and r are variables. So because you want change in v, you can write it as v is equal to this root of this, and these are constants, means you can take root r. V is proportional to root r. V is proportional to root r. So we can write v2 by v1. v2 by v1, if you take, it is equal to square root of r2 by r1, directly proportional, because r2 is 4r. You take 4r by r, you get r cancel, you get root 4 is 2. So v2, from this you can say that v2 is equal to 2v1. Once you get this relation, now you can get the percentage change in velocity. So delta v by v1 is equal to v2 minus into 100 is equal to v2 minus v1 by v1 into 100. I hope you guys are following this. So v2 is 2v1. So 2v1 minus v1 by v1 into 100. So 2v1 minus v1 is what? v1. v1 by v1 is 1. So into 100 is 100. So we'll get 100%. So I have to change, that is delta v by v into 100 is equal to, v1 into 100 is equal to 100%. The velocity should be increased by 100%. This is the meaning of the question. So you can now look into this question number 25, right? Yes. So it should be increased by 100%. 100%. This is the one. Okay. Next. See question number 20. Next alternate question, 27th one. A person wants to drive on the vertical surface of a large cylindrical wooden well, commonly known as death well, in a circus. The radius of the well is r. Keep this in mind carefully, guys. This death well application is important. We have discussed this in the session also. If you have not remembered, go to this one once properly. These applications, and keep in mind these points. Death well. Okay. Again, I'm repeating the question. A person wants to drive on the vertical surface of a large cylindrical wooden well, commonly known as death well, in a circus. The radius of the well is r, and the coefficient of the well is mu. Coefficient of the well is mu x or mu s. Coefficient of the well is mu s. Static friction coefficient, you can call it as maximum static or static. The minimum speed the motorcycle must have in order to prevent slipping should be. Without slipping, if the motorcycle wants to move in a circular path, that what should be the minimum speed? What should be the minimum speed? If the speed decreases than this, it will skid. So what is that? So to understand this, let us try to draw a diagram related to this. So question number 27. For question number 27. A death well is nothing but a cylindrical structure. Death well is nothing but a cylindrical structure like this. It should be a cylindrical structure like this. Okay. When a person is like in a what you call as a cylindrical structure, usually in a circus you may see globes. Motorbikers will move in the globes. Just if it is spherical globes. Okay, the motorbike is there will sometimes it will go and it will be moving doing the circles like this. Okay, horizontal circles like this. Here the vehicle is moving in this circular paths. We call this kind of paths as what you call a death well. It can be spherical or cylindrical also, but Same concept will come here. If the vehicle, if you consider this is a body, is the vehicle, because of its mass, mg will act downwards because of contact. If a body is on a surface like this surface, normal force acts, a normal force will act normal to the surface, in this case upward. Here normal force acts in this direction, normal force acts in this direction. But if only mg is acting there, this body will slide down. But it is not sliding and it is acting up, means what will be that? Just a second, guys. Sorry, guys. Excuse. Excuse. Yes. Yeah. Yes. Let's go ahead now. Let's go ahead. So it is question number 27, right? Yeah. So let me go to the question once again. A person wants to drive on the vertical surface. This is a vertical surface, right? A person wants to drive on the vertical surface of. It's actually, you have to consider three-dimensional structure, guys. On the vertical surface of a cylindrical wooden well, commonly known as death well in a circus. The radius of the well is r. So radius of this well, if you consider this is axis, so the radius will be nothing but r. This is the radius of the well. Radius of the well is r. And the coefficient of friction on this surface will be mu. Coefficient of friction on this inner surface will be mu s. It is mu s. The minimum speed, the minimum speed the motorcycle must have in order to prevent this skidding is. So why this comes into picture is, if only weight is acting here, mg act downwards, it will skid down actually. But without skidding down, the vehicle is moving, means there will be some force which is holding it. That is called as, because of this coefficient of friction, friction will act in upward direction, friction force. This will be balancing it. Here the normal force acting in this direction, right? This, because this is in a horizontal circular motion, this normal force provides the normal force. Yes, guys, a normal force provides centripetal force. So you can say normal force provides centripetal force, and it is equal to mv square by r, centripetal force. But here friction force is a balancing weight. That's why it is not skidding down. Otherwise, it will skid down. These two are equal. So you can also say friction force F is equal to mg. Okay, like you can consider this is another equation. But friction, by loss of friction, you can say also frictional force is equal to mu n. So n is mu square by r. So if you substitute it here, you can write it is equal to mu s into n is mv square by r. So if you substitute this here, then you will get mu s into mv square by r is equal to mg. Here, on simplifying this further, you will get the minimum speed required v. So from this you can write it as, what you can write, v square is equal to, by cross multiplying, if you send here, you will get v square is equal to rg by mu s. So v is equal to square root of rg by mu s. Square root of, is it rg by mu s? Yes, Cross check that. So you can say from this implies V is equal to square root of Rg by mu s will be the minimum speed. So which option is right? Accordingly, you have to work with this concepts of depth well. Square root of Rg by mu s. First option is right. First option is right. That's it. Next, question number 29. Let us see the question number 29. It is given that a stone is attached to one end of a string and rotated in a vertical circle. Vertical circle questions now started to see here. Vertical circle. If the string breaks at the if the string breaks at the position of maximum tension, it will break at it will break at where it can be break at the maximum possibility where the possibility will be there. We know that to understand that we know that when a particle is under when a string is when a particle is attached to a string and it is in a vertical circular motion, maximum tension it will possess at bottommost point. At any other point the tension will be lesser. Even if tension increasing gradually, first tension breaking tension will be reached at this point only, the bottommost point. So there is a possibility for the string to break at this point only. So what point? At point A. So this is the proper answer for this. So we can read the question once and understand clearly. A stone is attached to one end of a string. One end of a string, there is a string, one to one end stone is attached, here it is holding, and it is rotated in vertical circle. If the string breaks at the position of maximum tension, where you can get maximum tension when it is speed is increasing gradually, tension can be maximum first at bottommost point. So it can break here only. That is the point. Okay. Next question number 29 done. Next 30, not 30, 31. Question number 31. Where we are having 31. Question number 31. Yes, let us copy this also and let us bring it down. Let us bring this down. Yes. Right. Yeah. So question number 31. Question number 31. So it is given that a particle is moving in a vertical circle. A particle is moving in a vertical circle. The tensions in the string when the tensions in the string when passing through two positions at angles 30 degrees and 60 degrees from vertical. From vertical. So with respect to vertical, okay, that is and also from lowest position are T1 and T2 respectively. Then which of the following relations is correct? This we have already discussed. Again, I hope we have gone through this and revised. If not, listen carefully and follow it. So what is given here? A particle is moving in vertical circle. A particle is moving in vertical circle. Question number 31. Right. Vertical circle. Okay. Lowest position, horizontal position, and topmost point. Topmost point. Now in this case, the question is the tensions in the string when passing through these positions of angles 30 and 60 at if they are T1 and T2, which is the correct option. So we already know that tension at any point, tension at any arbitrary point is T is equal to mg cos theta plus me square by r we have got. So if you didn't remember that, just consider general case here. If the string is here somewhere here, having length L as the radius, this is length L as radius, okay, and if it is at some arbitrary point at an angle theta, and if provided if this is mass is m, so that mg is down, and if this is also theta, so this will be mg cos theta. So here tension will be acting in this direction, tension will be balanced by this. So net force due to tension and mg cos theta will provide centripetal force. Net force is centripetal force. So we can say T minus mg cos theta, because T is in towards the center. Centripetal force also will be in this direction, so this will be dominating one. So T minus mg cos theta will give you Fc, that is centripetal force. It can express it as mv square by r. Here r is nothing but L. Okay, so from this you can say T is equal to minus mg cos theta, and here it becomes plus mg cos theta. We can write it as mg cos theta plus mv square by r. This is the value of tension at any arbitrary point. Where v is the velocity at that particular point. So, but velocity, even if you want to replace this also, just in terms of angle only, then we have to just keep in mind that v is equal to square root of 2gr into 1 plus cos theta. Just especially that you can obtain v at any arbitrary point by using what you call law of conservation of energy. Then you will get one equation here. Total energy will be potential energy plus kinetic energy. Kinetic energy is a half m v square here at this point, or v1 square, plus kinetic energy plus potential energy is 0. This is equal to here potential energy is mg. H will be mg into h is equal to you can take this height is nothing but, if this is r into this will be r cos theta. So h is equal to r minus r cos theta. So mg r into 1 minus cos theta will be mg h, plus at that particular point velocity will be v, so that its kinetic energy is half mv square. Got it? So by making use of this, you can substitute here and you can simplify. So but you are asked to find which relation is correct here, so no need to do all these simplifications. So in simplest way, just you have to compare. For comparison purpose, you can simply say that if theta increases, what happens? With the increase in theta, you can say velocity will decreases. One point, velocity will decreases. The other point is, in this, as theta increases, if theta increases, cos theta will decrease, and hence for this term will decrease, right? So if cos theta decreases, tension also will decreases. So with increase in theta, one thing, with increase in theta, velocity will decrease. Here only it will have maximum velocity, then velocity decreases and it becomes here root 5 gr it will have, here at root 3 gr it will have, here root gr it will have. So velocity decreases. So with increase in theta, velocity decreases, and theta cos theta also decreases. So overall you can say tension decreases. So by using that condition, simply without doing all these simplifications, by using that condition, we can say that simply we can say here, as theta increases, number one, v decreases, so this decreases, and number two, cos theta also decreases. So that means this also decreases. Both terms decreases means tension will decreases. So therefore T decreases. So what is that? If theta increases means, we are considering only 2 points, 30 degrees, 60 degrees point. 30 degrees means here, 60 degrees means somewhere here. So if it goes here, tension decreases further. If tension at 30 degrees is T1, then T2 is tension at 60 degrees. So T1 will be more than T2. T1 will be greater than T2. So that is what you can understand. So that implies, therefore, you can say T1 should be greater than T2. So this is the correct option. Simply you can say this one. Okay. Next question. 31 is low. Then 33. 33. So what is given here? Let us see the question. Let us see the question here. The question is, a bucket full of water is rotated in a vertical circle of radius r. If the water does not split out, the speed of the bucket at topmost point will be the speed of the bucket of speed of the bucket or speed of a stone or any body at topmost point. We can say it is not split out means it is moving with the minimum possible velocity, called as critical velocity at that point. That is the meaning of it. So minimum possible velocity required for that will be root gr. Under that condition, speed of that bucket at the topmost point will be root gr. This is a conceptual question. So don't need to think what is bucket to water, this and that. It is a conceptual point. So if water not to be spilled out, if the speed is less than this, if you are let us see here. What is that question number? 33. If you are rotating a bucket like this, okay. If it goes here, if the speed is and less than critical velocity here, that is root gr, then it will not go here. If it is having velocity here is root gr, means the critical velocity here should have moved with root 5 gr. Then only it will possess root gr here by the time it goes here. Okay, got it? Got it? So otherwise, it should have not reached here. If it is less than that, it will go somewhere here and fall down. That means water will spill out. So if it is equal to this or greater than that, then it will not spill. So minimum speed, you can say that minimum speed of the bucket at the topmost point should be, if it is not spilling means it should be root gr. That is what you have to understand. So option 1 is right one. Okay, so it should be equal to root gr. Next question number 30, not 435. Question number 35. What is given here? A car, when it passes through a convex bridge with velocity v, exerts a force on it at the topmost point is equal to. We have discussed these two kinds of cases: convex surface and concave surface. If there is a convex bridge, let me draw this little. My game is not selected. Yeah. Like this. So we have a convex bridge. This is a convex bridge. Let's call this convex bridge. Question number 35. When a car passes through a convex bridge with velocity exerts a force on it at topmost point. If this is a topmost point, how much force it will exert on the bridge is the question. On the bridge, how much force it exerts at the topmost point. If it is having mass m, mg will act downwards, and of course normal reaction will be on upward direction, right? When it is moving like this with velocity. If it is actually a convex bridge means should be a part of a circle. You can say this will be a center of a circle. Okay, here it will be a part of a circle. So we can say that if it is moving, the net force in this direction will provide the necessary centripetal force. That's why it is a part of a vertical circular motion. We have discussed this concave and convex bridges. So net force will be mg minus n, because the centripetal force will be towards center. The force which is acting along this towards center will be the net maximum one. We can dominating one, so we can take it as mg is maximum. So mg minus n will be mv square by r, centripetal force, and hence here what we are asking to find, how much force it exerts on the bridge is the question, right? So how much force bridge exerts on it, that much force it exerts. How much force it is exerting on this? Normal force, that much it will exert. So you can say normal force from this is equal to, if we take it here it becomes plus n, so we have to bring it here, then it becomes n is equal to mg minus mv square by r. This much force the bridge exert on the vehicle, that same force it will exert on the bridge. So this is the one. So mg minus mv square by r, mg minus mv square by r is the option 3. Option 3. That's it. Simple. Similarly, we have discussed about what is the concave bridges also. It is the lowest point. What is that force exerted by this also? Here n will be here, mg will be here. Accordingly, if you take this as radius r, here n will be dominating here. So n minus mg will be equal to centripetal force. N minus mg, the reverse way we will get it. So in case of concave bridges, try to keep that in mind. Next, define is over 37. 37. If a particle of mass m is circulating on a circle of radius r having angular momentum L about the center, then centripetal force, even though you are getting the term angular momentum that comes in rotational motion, don't confuse here. Even you can relate both of this. So, what is centripetal force? We have to relate this as question number 36. What is given here? A particle of mass m is circulating in a circle of radius and having angular momentum L. Angular momentum L. So how to relate centripetal force and angular momentum? You have to keep that in just you need to have an idea about it. Uh, what is the centripetal force is the question. What is the centripetal force? We know centripetal force is equal to mv square by r. mv square by r. How to relate this with angular momentum? Let us say this is equation 1. We know that, we also know that angular momentum L is equal to mvr. Angular momentum is nothing but what? Mvr. So here, if you want centripetal force in terms of angular momentum, so it is equal to mvr. Let us replace this either any of these terms with L, either m or v or r. So r is equal to L by mv, or m is equal to L by mvr, or v is equal to any of these terms, no problem. Okay, then what do we get here? Then let us consider here, let us say these are constant variables, right? The m and r are constant, only velocity will changes, so centripetal force will changes and angular momentum will changes. So if you take this v is equal to, from this, v is equal to L by mr if you take, and if you substitute this over here, then we get Fc, centripetal force, is equal to m by r into v square, means this whole square, that is L square by m square r square. So you can write it as m, one m gets cancelled here, so it is at the end what will you get? L square by r square into r becomes r cube, m r cube. M r cube will be centripetal force. L square by m r cube will be centripetal force in terms of L. L square by m r cube. L square by m r cube. L square by m r square. L square by m r. L by m r square. So L square by m r cube. That's it. This is how we have to relate. So you need to just play with the expressions. That's it. Next, question number 39. See here, a stone is rotated in a vertical circle. The stone is rotated in vertical circle. The speed at the bottom most point is root 8gr. Usually, if it is root 5gr, then it completes vertical circle. Minimum required is root 5gr. If it is having root 8gr, it is happy it will complete the vertical circle. If at the bottommost point the speed is root 8gr, where r is radius of the circle, the ratio of tensions at the topmost point and the bottommost point, what will be the expressions for tensions? What will be the expressions for tensions at topmost and bottommost points is the question. Tensions. So how can you get this? How can you get this tension in terms of this? We have to have, already we have discussed the expression for tension in terms of velocity, right? So by using what actually speaking the law of conservation of energy, you can get that. Okay. So let us do it briefly. You see here question number 39. Question number 39. Question number 39. So what is the time, guys? Oh, hello guys. Already is time up, Prana. Is 8 o'clock. So let us try to work out these remaining questions later. Then already some of you have left. Okay, then just I'm winding now. This remaining questions we'll see later in the next study hour. I'm winding.